Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now answering question number 6 from the January 2022 International A-Level Edexcel Pure Mathematics P3 paper. It says the function f is defined by f of x equals 5x minus 3 over x minus 4, where x is greater than 4. Now, sometimes a lot of students, they don't take much notice of these little kind of points or little conditions mentioned next to a function. But in P3 especially, it's very important that you do, because sometimes you're asked to find the range or the domain of the function or the inverse function, and this then becomes very, very important. The domain, this is the domain of this function, meaning basically this function only exists when x is greater than 4. There's no values of x that can be less than 4 for this particular function, because that's how they defined it. So that affects many things, especially later on. So it says, show by using calculus that f is a decreasing function. So this function f is a decreasing function. Now, that means for all the values that this function is defined for, which means when x is greater than 4, we have to show that this will always be a function that is falling, never rising, falling the whole time. Okay, for those values of x, for which this is a decreasing function. Okay, for those values of x for which this is defined, it will always be a function which has a negative gradient. Okay, so to basically, a decreasing function is one where the gradient is always negative. An increasing function is one where the gradient is always positive, because the decreasing function is always falling, increasing function is always rising. So we have to show that f dash of x will always be something that is less than 0. Okay, that's what we have to show. We have to prove this. So first of all, we've got to find f dash of x. Now, f dash of x is when you differentiate this with respect to x. Now, to differentiate this with respect to x, we have to use what's called the quotient rule. Okay, so the quotient rule, when you have a quotient of two functions, two different functions basically on top of each other. All right, two different terms on top of each other. So you have u equals 5x minus 3, and the other function is v, which is x minus 4. So we can say here u dash, the differential of 5x minus 3 is 5, and the differential of v dash is 1. If you differentiate that, you get 1. And for the quotient rule, you always start with the v on this side. I like to write them on top of each other like this. It makes it easier. So I start off first with this side. I have that times that. So I have 5 times x minus 4 minus these two multiplied, which is 1 times 5x minus 3. And then you divide it by v squared, which is x minus 4 all squared. That's the quotient rule. And it's actually quoted in the formula book, the quotient rule, I think. It is. All right, the quotient rule is quoted in the formula book. And it's when you multiply these two, and then these two, subtract them, divide by x minus 4 all squared, divide by v squared. You also have something called the product rule. If you have a product of two separate functions, then you can use something similar, but it will be v times u dash plus u times v dash, and that's it. And some people will use the product rule for this. For example, they might express this as 5x minus 3 times x minus 4 to the power of minus 1, and then they would proceed to use the product rule for this. But for myself, I think this is a bit simpler. Anyway, so now what we can do now is simplify this. So we have f dash of x is equal to 5x minus 20 minus 5x plus 15. So not plus 15, what am I talking about? Minus 1 times minus 3 is plus 3. Okay, minus 1 times minus 3 over x minus 4 all squared. I'll leave this in this bracket form here. You'll see why in a minute. So therefore we can say f dash of x is equal to 5x minus 5x, which is 0, negative 20 plus 3, which is negative 17, over x minus 4 all squared. Now, we know that, x is greater than 4, all right? So we can say for all values where x is greater than 4, we can say x minus 4 squared will always be greater than 0, therefore positive. Okay, we can see that. This is always going to be positive. When x is greater than 4, okay, this is always going to be something that's positive. When x is equal to 4, this is going to be equal to 0, okay, which is going to be, cause this to be undefined. So when x is greater than 4, which is the condition here, we know that this is always going to be positive. So for all values of x is greater than 4, this is going to be greater than 0. Therefore, we can say f dash of x is going to equal, it's going to have a negative value, negative 17 over a positive value, which is therefore negative. So therefore, f dash of x is less than 0 for all possible x values. Okay, for all possible x values, meaning x is greater than 4, therefore it's a decreasing function. Therefore, decreasing function. A decreasing function is one where the gradient will be always negative. Right. Sometimes they might have a question that says find the values of x for which a function is decreasing. Then you'd have to solve an inequality like this. You have to find the gradient function and then set that to less than 0 and solve the inequality to find the values of x for which it is decreasing. Here they're telling us to show that it is a decreasing function, means for all values of x. And even if it didn't have this condition, if the condition was just x can't equal 4 because it can't equal 4, this would also be a function which is decreasing. Okay, because it looks like that the graph of this function is going to be something that looks, something has this type of shape. Okay, it has this type of shape where it's always decreasing, always has a negative gradient. Seems like it might have this shape here. Okay, 5x minus 3 of x minus 4, always going to have a negative gradient. Okay, we know that the asymptote, if we try to picture it, the asymptote of this function is going to be y equals 5, because when you divide these you get 5, you're going to have a whole number of 5, and the x asymptote is when x equals 4, and when x is 0, you get f of x is 3/4, so it's going to cut through here. All right, when y is 0, you have x equals 3 over 5 over here. So yeah, so it's going to go like this for sure. It's going to have this type of shape. That's where it's going to go, and we can see that it's going to have a negative gradient always have a negative gradient. Okay, even when x is less than 4. Okay, with this particular function, actually won't have anything on this side because we can see that x is only greater than 4, so it's only going to have something over there. However, we can see that it's, even if it did, if this condition wasn't there, it would always have a negative gradient anyway. Okay, the whole time. All right, so that's just part A. A little bit of extra information there. Whoops. Yeah, that's fine. Okay, so that's part A. Now for part B, it says find f to the power of minus 1, means the inverse function. We've got to find the inverse of f of x. Now to find the inverse of a function, we take the original function, and first of all what I do is I replace the f of x with y. So if y equals 5x minus 3 over x minus 4. And then I replace the x with the y and the x with each other. So y I'm going to call it x, and x I'm just going to call it y. So I'm not rearranging it, I'm just renaming, okay, the x and the y. Because when we find the inverse, we're kind of switching the axes. And then what I'm going to do is I'm going to make y the subject of this formula. So I'm going to multiply both sides by y minus 4. So I'll have x times y minus 4 equals 5y minus 3. And I'll expand the brackets. I'll have x times y minus 4 times x equals 5y minus 3. Now I want to make y the subject of this. Then I'll have the inverse. So to make y the subject, I can bring the y's on one side of the equation and everything else on the other. So I have xy minus 5y equals 4x plus 3. Okay, minus 3. 4x minus 3. So minus 3 plus 4x. So it's going to be 4x minus 3. The minus 3 stays there, and you have to add 4x to both sides. Now I'm going to take out the common factor in this side of y to make y the subject. So I have y times x minus 5 equals 4x minus 3. So therefore I can say y is equal to 4x minus 3 over x minus 5. So that is the form of the inverse function. So I can say that the inverse function is equal to 4x minus 3 over x minus 5. Now, when you write down the inverse function, even if they don't tell you to do so, you have to write the domain of the function. You must state what its domain is, and especially when the domain of the original function has been kind of restricted, we have to therefore give the domain of the inverse function, because it's going to be affected by that restriction. So there's two ways we could proceed. I could find the domain of this function by just thinking about how it looks, or I could find the domain of this function, or the range of this function, okay, according to this restriction. I could, find the range of this function, which would be the domain of that function. So what I'm going to do, I'm going to show you exactly how did I work out what I worked out earlier, without actually doing much algebraic long division or anything. Now I know that this function, if I was to sketch it without any restriction, okay, as I just showed you above, okay, in the first part of the question, all right, I'll leave it like that. I know that definitely when x equals positive 4, this is going to have a asymptote. That's quite obvious, because when x equals 4, this is going to be an asymptote here for sure. This will be undefined. So x can't equal 4, right? So that means x equals 4 is an asymptote of this graph. We know that for sure. I also know if I do algebraic long division and I divide these, I'm going to get 5 and then plus a over x minus 4. Right? Now I don't really need to work out what that's going to be. I know that there's going to be a 5 here, which means it's a transformation of, basically 1 over x in such a way that you have to add some 5 to it. So the horizontal asymptote that is for 1 over x is moved up by 5 units. So I know, because 5 divided by 1 is going to give me 5. So for sure I'm going to end up with a 5 when I divide them as my whole number part, right? So I know that for sure there's going to be an asymptote at 5. Okay, at y equals 5. So y equals 5 is another asymptote. And as I just mentioned to you just now, there's two ways we know that the graph, it could either go on this side and this side, okay, which it does, or it can go on this side and that side. Now, how do you know which one it is? Okay, well, what we do is we can think about two things. One of them is the fact that we know that this is a decreasing function, so the gradient's always going to be negative. If it was going on this side and that side, the gradient would always be positive, because something like this and this, the gradient will always be positive. So that's one clue that it must have the other direction. And the other clue is in finding the places where it crosses the x-axis and the y-axis. Now this crosses the x-axis when y equals 0. So when y equals 0, you got 5x minus 3 equals 0, because you have to make this 0. So x is 3/5. So it's going to cross the x-axis at 3/5, somewhere like this. And when x is 0, it crosses the y-axis. And when x is 0, you're going to have y equals minus 3 over minus 4, which is 3/4, which is going to be up here somewhere. So it's going to cross the y-axis at 3/4. So we can see that definitely it must pass through these points like this. And therefore it's up here. And you can see that also matches with what I mentioned before, that it always has a negative gradient. Now, this is restricted, okay, for x is greater than 4. So I can actually now just get rid of all of this side, because this function only exists where x is greater than 4. All right, and the domain of the original function is the range of the new function or the inverse function, and vice versa. So if I want to find the domain of the inverse function, which is what I have to quote here, then I need to write that down as a range of this original function. Now the range of this original function is going to be all the values it can take on the y. Now this is going to go up forever. This is 5 here. So the range is y, the range is y is greater than 5. It will never touch 5, but it's always going to be above 5, and it's going to go up to infinity. So y is greater than 5 is a range of this function, which means, therefore, the domain of this function is x is greater than 5. The range of the original function is equal to the domain of the inverse function. So that's how you can quite quickly work out what the domain of the inverse function is by thinking about the range of the original function, and you can do that quite easily by working out the asymptotes. The x asymptote is the value of x that makes this whole thing 0, which is x equals 4. The y asymptote is what you get when you divide these two, and it's normally the coefficients here. If you divide them, it will give you, the value you need. So it's 5 divided by 1 is 5, so that's the y. That's the asymptote on the y-axis, the horizontal asymptote. And to work out whether it's going to be in this side and this side, or that side and that side, I mean, in this question, because we know the gradient is always 0, we can use the fact, the only way the gradient will always be 0 is if it's in these two sections. Or you can try to find, as I said, the x and y, what's it called? The x and y intercepts. All right. So, for example, here there is an x and a y intercept. If it was the other way around and it was in these two parts, you wouldn't find any y. You would find an x asymptote over here somewhere, and the y asymptote above, further up from the so x intercept, further along from x equals 4 and higher up than x equals y equals 5. You would find the asymptote, the intercepts, in those places. So that's part B done. Now we're going to go on to part C. Now part C says show that f of x equals ax plus b over x plus c, where a, b, and c are constants to be found. Deduce the range of f. All right, the function. Now this is called a composite function, where we are substituting the function inside itself. This could also be expressed as f squared x. That means the same thing as this, f of x. So we're going to replace when you find the composite function, you take the function and you substitute into it, what comes after it. So fx is put into the function f. So that means we have to find the f and substitute inside it itself. So 5x minus 3 over x minus 4 has to be substituted inside this function itself. So if, for example, if I was finding f2, I would replace the x with 2. I'm finding 5x minus 3 over x minus 4. I have to replace the x with the whole of this expression. So f of x, therefore, is going to become, I'll have 5 times all of this, 5x minus 3 over x minus 4 minus 3. And I'm going to write it like this so that it makes it less confusing. Then I'm going to put divided by, and replace the x in here with also 5x minus 3, x minus 4. So 5x minus 3 over x minus 4 minus 4. Okay, so it's basically 5 times this whole thing, minus 3, divided by this whole thing, 5x minus 3 over x minus 4 minus 4. Right, so now I can simplify this. This is going to be 5 times 5x minus 3. Remember, this is like 5 over 1. So it's 25x minus 15 divided by x minus 4 minus 3 divided by, and I'm going to have here, now what I'll do, this is already ready for me to make it into one fraction. So that's x minus 4 minus, make the x minus 4, have to multiply this by x minus 4. So I have 5x minus 3 minus 4 times x minus 4 there. Here I'm going to do the same thing. I want to write these two as one fraction. So I have x minus 4 and 25x minus 15 minus 3 times x minus 4 over x minus 4. This is divided by, now I can write this as one fraction of x minus 4. This is going to be 5x minus 3, and this is minus 4x plus 16. Okay, plus 16. So minus 4 times plus 4 is plus 16. Yeah, so that's this one. Now I can also simplify this fraction, put it under one denominator, x minus 4. So I have 25x minus 15. That's going to be minus 3x and plus 12. Okay, divided by, let me simplify this. This is going to be x plus 13 over x minus 4. Let's simplify this one. So you have 25x minus 23 minus 3x, which is 22x, minus 15 plus 12, which is minus 3. okay, over x minus 4, and then I can multiply that by this fraction, which is x minus 4 over x plus 13. So I end up with them cancelling out. So I've got 22x minus 3 over x plus 13. So I've got f(x) therefore is equal to 22x minus 3 over x plus 13. Okay, that's the inverse function. Then it says deduce the range of this function. Okay, so that's the next part of this question. And now for question 6, part 2, it says deduce the range of the function ff, the composite function ff. Now we've already found that f of x equals f of fx. The composite function is 22x minus 3 over x plus 13. We know that there is a condition to the domain of the original function f of x, which is x is greater than 4, which of course will mean that this is also, going to have that restriction. And we're going to think about how this function looks so we can see what the range will be properly. So what I'm going to do is I'm going to make a little sketch of this function. Okay, I'll make a little sketch of this function. Now, this function will have an asymptote at x equals negative 13, which doesn't really affect us because as x equals negative 13. Let me make this a bit smaller scale so that I can fit things on here. And also at y equals 22, because when you divide this, you're going to get 22 as your whole number. So there's going to be another asymptote at y equals 22. So I'll just draw that up here somewhere. Okay, y equals 22 is the other asymptote. So those are the two asymptotes. Now, where will this graph, how will it look? Will it go on this side or that side? Well, we can do a little, we can say when x is 0, we'll see what y is. When x is 0, y is negative 3 over 13. So when x is 0, y is going to be down here somewhere. Negative 3 over 13. And when y is 0, then you're going to have 22x minus 3 is equal to 0, which means that x is going to be 3 over 22. So it's going to go 3 over 22. So it's going to go looking like this. So basically the graph will look something like this. Look something like this. Now, we don't have to worry about this part of it because it's also going to go over here. We don't have to worry about any of that part. But what we have to worry about is from 4 onwards. So let's say this is x equals 4 over here. Let me make it a bit closer to this. Let's say x equals 4 is over here. Let's say that's x equals 4. So we have to worry about it from where f of x is greater than 4. So I'll have an open circle here. And I'll get rid of the rest of this graph. Whatever's on this side, I don't need it. So our graph only exists from this point onwards. This is the only part of our graph. Above there's an asymptote. It'll never go above here. And it'll never go below this point here. So we've got to work out what this point here is when x equals 4. We're going to find what our function ff is. So you're going to have 22 times 4 minus 3 over 4 plus 13. So that's going to be 88 minus 3, which is 85 over 17. I think 17 times 5 is 85. That's right, that's 5. So this is actually 5 here. So we can say the range of f of x, the range of f of x is going to be when y is between 5, greater than 5, and up to, but not including 22, because that's the other asymptote. So that is the range of the function f of fx. So having an idea of what the graph looks like and being able to sketch it really helps you to be able to work out the range easily. So there's the answer for question number 6, and that completes this question. Other questions from this P3 January 2022 International A-Level paper can be found in the playlist over here. Other questions that are to dealing with functions in P3 can be found in this playlist, and you can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.